All right, class, the last and final section we're going to learn in this unit is about inverse functions. An inverse occurs when the x and the y change positions. So y equals x squared plus 7 would have been our original function. When I change the position of the x and the y, it becomes x equals y squared plus 7. Graphically, here's how we do this. What we want to do is change the position of each x and y. So the 0.39 is actually going to become the 0.93 in our inverse. The same with 2, 4. It's going to become 4, 2. When I change the position of the 0.11, it stays the same. The same is true with 0, 0. For negative 1, 1, when I change that position, it ends up being 1, negative 1. The same with 2, 4. And negative 3, 9. So the blue would be the inverse of the red function. Technically, an inverse function is when we flip the function over the line y equals x. When I draw the line in, if you notice, each point is the same distance away from the line y equals x. Which means that it would truly be the inverse of the function. An inverse function is a flip across the line y equals x. If I want to find the inverse of a function, all I have to do is change the position of the x and y and solve for y. So this is my original function. To find the inverse, I need to change the positions. So it becomes x equals 2y minus 1. And then I want to isolate the y. So I'll add 1 to each side. And then I'll divide by 2. So my inverse is going to end up being y equals x plus 1 over 2. Notation-wise, I indicate the inverse by using a little 1 in the power position. We say that f prime. So if you ever hear me refer to f prime, that's referring to the inverse. Inverses also can represent composite functions, and we will talk about this more in class. Have a good day.